Welcome everyone. So by special request, we're going to go over this problem from one of the previous problem sets. This is, I believe, problem number 5 from the problem set for lesson 12.1. This happens to be problem number 2 on the 2000 AIME I. So I just want to go through this here. So we're told that Q and R are positive integers with zeros less than R is less than Q, so it's positive. Let A be a point QR, so that means this is in quadrant 1. B is the reflection of A cross Y equals X, and so on and so forth. So I guess we're going to try to figure out what's going to go on here. So B is a reflection of A cross Y equals X. So remember that Y equals X switches the order of the coordinates here. So this becomes B R comma Q here. Okay. Let C be a reflection of B across the Y-axis. So when we're reflecting across the Y-axis, just the X coordinate negates itself. So we're left. So this is C at negative R comma Q. D is a reflection of C across the X-axis. So again, we do this here. Now we're going to reverse that coordinate in this situation here. So we get D is negative R comma negative Q. And finally, E is the reflection of D across the Y-axis. So E is going to end up over here. E is going to end up at the point R comma negative Q. We are told the area of pentagon ABCD is 451. So if we sketch this, our pentagon looks something like this here. Okay? Alright, so the first thing to note is that it looks very much like a rectangle. In fact, it almost kind of is. The only difference is that there's this extra jump piece over here. So I'm going to go ahead and slice it like so. We can see that we have a rectangle like this, and then BE here acts as the vertical side of a triangle. Alright, so let's have a look at what's going on here. Now, note that this rectangle has pretty easy dimensions here because we this from R to negative R. This is a distance of 2R here, so we have 2R in this case. And here from C to D, it's 2Q, right? Because we're Q units above the X-axis and then go Q units below it. So we have 2Q here. All right. Now, in this situation here, so we know that the area of this is going to be 2R times 2Q, which is the rectangle. Now we need the triangle as well. Luckily, this is 2Q, but now we also have to figure out the height of the triangle. And that's not too bad, because remember that the height is a horizontal distance here. So we kind of see this. So we see our horizontal distance like that. Notice that R is greater than Q is greater than R here. So that means here we're basically looking at X coordinates, right? This is the X coordinate R, and this is the X coordinate Q. So that means this here is going to be Q minus R. All right? So now let's actually put everything together. So we know that the area of ABCDE is 451. Now, this analysis that I just did here, you could also just use a shoelace formula for this, and that's perfectly fine with that. Anyway, so we're going to write this out. 451 is going to be the area of the rectangle, which is going to be 2R times 2Q. And then we're going to add the area of the triangle, which is going to be 1/2 the base, which is 2Q, and the height, which is Q minus R. Okay, so that means 451 equals 4QR plus, well, the 1/2 and 2 drop out, and we're left with Q times Q minus R, which is Q squared minus QR. Now we can combine these here, so we get 451 equals Q squared, what appears to be plus 3QR. And I think this is where a lot of you got. Here. Now, where do we go from here? Well, as I mentioned in the hint, this can be factored. So I can write here, there's a Q in this, so I can yank out a Q, and I'm left with Q plus what appears to be 3R here. So now here's the key. And this is where some of you got kind of stuck. This actually is a relatively common thing when it comes to contest problems in the math team world here. Note that we're told that Q and R are positive integers here, right? This means this is an integer, and we have an integer plus 3 times an integer, that's also an integer as well. So we've got 2 integers that multiply to 451. This means if I have 2 numbers that multiply to 451, these are both integers, that means these have to be factors of 451. So what we're going to be looking for is we're going to be looking at factors of 451 here. Now 451 is actually very nice here, right? Because 451 actually doesn't have a lot of integer factors here. In fact, 451, you note that the center digit is the sum of the outer two. This is the telltale sign that this number is divisible by 11. So this is actually 11 times 41 here. And note that these are both primes, so that's actually really good, which means that we don't have a lot of situations here. So there are 2 cases to worry about here. And by the way, note that since R is a positive number, it's pretty clear that Q plus 3R is greater than Q. So that means this is going to be the bigger number in each pair. So in fact, even though technically we should test the different orders here, so like for instance, putting a 41 here and 11 here, note that since this is positive, we know that this is going to be a bigger number here. So in fact, there are 2 cases to worry about. Our first case is if q equals 1 and q plus 3r is 451, right? That's going to be the case here. So we've done do this thing, so this means that 3r equals 450, so r is 150. However, if you note that this is the case here, r equals 150 and q equals 1, that does not satisfy r is less than q here. R is certainly bigger than q. So we have to throw out this case. This case doesn't work. Oops, sorry. We have to throw out this case. This case doesn't work here. I apologize about that. So that means there's only one other thing to do is just say let q equals 11. So if we let q equals 11 here, then we have q plus 3r is 41. So that means 3r is equal to 30, right? Because that's we have an 11 here and that's 41 here. So we get 3r is 30, so therefore r is 10. And we know that that does satisfy the situation that we had at the beginning where r is less than q. So that's the case here. Therefore, since we're asked to find q plus r, and that's just 11 plus 10, which should give you 21. Blackjack.